Study Guide 7, number 9. Page 2, this is number 9. A monument casts a shadow 37.8 feet long, and I think the picture's already drawn for us here. A man is 6 feet tall, casts a shadow at 10.8 feet. The triangle drawn with the monument and its shadow is similar to the triangle drawn with the man and his shadow. How tall in feet is the monument? So we can set up a proportion. So I'm going to match up the height of the statue to the height of the man. So I'm going to say x over 6 is equal to shadow. So I started with the larger triangle, so I'm going to start with the larger one here. 37.8 is to 10.8. So let's cross multiply. That's the easiest way to solve the proportion, and I get 10.8x is equal to, and I think I'll go over here and do the 37.8 times 6. 48, carry 4. 42 plus 4 is 46. 18 plus 4 is 22, and I have one decimal place. So we have 226.8. Divide both sides by 10.8. And I think we can do the division right here. 10.8 into 226.8. We need to move our decimal over in the divisor and the dividend. It goes 2 times. And I get 216. Subtract, I get 108. 108 goes into 108 exactly one time. And we get 21. And remember, our units were feet. So the monument is 21 feet tall. Number 10. A model airplane is constructed using a scale factor of 1 centimeter is equivalent to 75 centimeters. So on the model is going to be 1 centimeter to the real-life airplane being 75 centimeters. If the actual airplane has a wingspan of 12 meters, how many centimeters long is the wingspan of the model? So they've got a little confusing thing going on here that they mentioned 12 meters. Since they want our answer in centimeters, let's go ahead and change our 12 meters to centimeters. So I've got 12 meters, and there are 100 centimeters in 1 meter. So we can cancel our meters, and 12 times 100 is 1,200 centimeters. So that is the wingspan of the actual airplane. So let's match it up. The scale model to the actual equals scale to actual. So I'm going to do a fraction equals a fraction. So if the scale is 1 to 75, and then the wingspan of the actual airplane is the 1200, then the x is what we don't want to know. What we don't know. We want to know the wingspan of the model. So we cross multiply, we get 75x is equal to 1200. Let's divide 75 into 1200. And let me find a good place to do that. I think I'm going to go back up here and do that. 75 into 1200. It goes one time into 120. Do a little borrowing here, and we get 5, and then we get 45. Bring down your 0. And I believe this will go evenly. Let's try 6, 30, 42, 45. So x is equal to 16, and our units were centimeters. Number 11, find the 74th number in the pattern. Well, I can see very quickly that I'm adding 7, but I prefer not to add 7 74 times. So I'm going to use the formula a sub n is equal to a sub 1 plus n minus 1 times d. That's not a real difficult formula to memorize, and it's one you definitely need to know when you're going way out there on sets of numbers. Just do a quick review. N is going to be the term we're looking for, because this is a sub 1, a sub 2, a sub 3, and so on, and we want to go way out here and find a sub 74. So we know that n is 74. Well, a sub 1 is the first term, which is 7. N is our same number here, 74 minus 1. And then our d is the number that we're adding to get from 7 to 14 and so on, and that was 7. So we have a sub 74 is equal to 7 plus 73 times 7. Let's do a little arithmetic. 21, 49 plus 2 is 51. So A sub 74 is equal to 7 plus 511. So A sub 74 is equal to, 74 is equal to 518. So that is the, if you go all the way out here and count out plus 7, 74 times, you'll get 518. Number 12. Which is the better buy? 4 pounds of tomatoes for $3.76 or 5 pounds of tomatoes for $4.65. So let's see what each one of them is per pound. So let's take the first one, the $3.76 divided by 4. And I think I need to scoot that down just a little bit. Let me just mark that out and do it over here. So we'll bring our decimal up. 4 doesn't go into 3, but it goes into 37, 6, 7, 8 times, 9 times. 36. Subtract, we get 1, and 4 goes into 16 exactly 4 times. So this one, the tomatoes are 94 cents a pound. So 5 into 465. 5 doesn't go into 4. 5 goes into 46 9 times. We really can't tell yet. But 5 goes into 15 3 times exactly. And so you've got 94 cents a pound for this set, 93 cents a pound for this one. So the best buy is the 5 pounds for $4.65. Number 13, you have a proportion. 2/5 equals k plus 3 over 15. Well, let's cross multiply. It's the easiest way to do proportions. If you like to do the variable first, we'll have 5 times k plus 3 is equal to 2 times 15. Distribute, you'll get 5k plus 15 equals 2 times 15, which is 30. Subtract 15, I get 5k is equal to 15 divided by 5, and k is equal to 3. Okay, number 14, the ratio of men to women in an exercise class is 3 to 4. In all, the class has 14 students. How many men and how many women are in the class? So let's set up a table. I'm trying to see where I have a good place to work that. Let's see. Let's go down here. I think we'll be okay. So I want to set up men, women, and total. And we have our ratio column, which is just simply the group reduced, and we have our actual column. So the ratio of men to women was 3 to 4, so the total of the ratio would be 7. But actually, we had 14 students. Well, you can see very quickly, and this is a pretty easy one, that you're just multiplying by 2, so you could see the numbers very quickly. But if you didn't see that, especially if they were decimals or something, a different money or something like that, let me go ahead and set it up for you, how I would work it if I couldn't see. Here, just times 2 would be 6, and times 2 would be 8. But let's work it. I'm going to go ahead and do all the algebra. So let's find the men. So I'm going to put x here. I don't need the women, so I can say 3 is to 7 is x is to 14. When I cross multiply, I get 7x is equal to 14 times 3, which is 42, divide by 7, and I get x equals 6, which didn't surprise us. That's 6 men. Well, you know if you've got 14 total, they're either men or women. Well, if the 6 are men and you subtract from the 14, you'll have 8 that are women. And you could have set the proportion up, but it's usually easier just to go ahead and subtract. Number 15, write the first 4 terms of an arithmetic sequence where a sub 1 is -1 and the common difference is 5. So let's go ahead and make us some blanks. 1, 2, 3, 4. A sub 1, a sub 2, a sub 3, and a sub 4. Well, we know the first term is -1, and D is the number that we're going to be adding. So if we add 5 to -1, we'll get 4. Add 5, we get 9. And add 5, we get 14. And we could keep on going, but they only ask for the first 4. Number 16, we need to know where this line crosses the x-axis and the y-axis. So let's set up a t-table. And I'm going to put 0 in for x first and get my y-intercept. And then put 0 in for the y to get the x-intercept. So if I put 0 in for x, I'll have 3 times 0 minus 5y equals 60. This becomes 0, and I'm going to go ahead and put all the steps in. Some of you use the shortcut. So 0 minus 5y is negative 5y equals 60. Divide by negative 5, and you'll get y is equal to, you got 60 over negative 5. Let me write that a little bit better. And that's negative 12. So when x is 0, y is negative 12. Now let's do the same thing for the x-intercept. And again, there are shortcuts there that you can skip over. Some of you go straight to this step here, and that's fine. We've got 3x. We're going to put 0 in for y, so we'll have minus 5 times 0 equals 60. We get 3x minus 0 equals 60. So 3x minus 0 is 3x equals 60. Divide by 3. And we get the x-intercept is 20. Number 17. Find the product of 5.6 times 10 to the 5th times 4.1 times 10 to the 6th. So let's group them together. So 5.6 times 4.1. 1 times 6, 1 times 5, 4 times 6, 5 times 4 is 20, plus 2 is 22. So we get 2296 with 2 decimal places. So we have 22.96 times 10 to the 11th. Now, you're going to have, and this is a big number, you're going to take that decimal place and move it 11 places to the right. It's a very large number. Well, if you have to move it back one space, some people can't figure out if it's going to be a 10 or a 12. Well, if you just ignore this number over here for right now and put this one in scientific notation, if the number is more than 9, then the exponent's going to be positive. So you've moved it one space to get this number here between 1 and 10. So we brought that down, and we've got our 10 to the 11th. This is the way the 7th grade book teaches it. So we now, if we group our 10s together, we have 2.296 times 10 to the 12th, and that is in complete scientific notation. Between 1 and 10, and then exponent of 10, power of 10. Notice the instructions on this one are not what's the GCF, but to factor completely. So we need to find the GCF and what's left over. The factor tree of 12c to the 4th d squared is 2 times 3 times 4c's times 2d's. 15 is 3 times 5 times 3c's times 4d's. And most of you are getting the point you can do these without the factor trees, but you know you can do them if you need to. So let's see what this is the GCF here. So let's see what they have alike. And I notice both of them have a 3. And then with C's, I see 1, 2, 3 C's. And I see 2 D's. So my GCF is 3 C cubed D squared. So in the first factor tree, I have 2 times 2, which is 4. I have 1C and no D's left. And then in the second one, I have a 5 left and no C's. And I had 2 D's alike, so I have 2 D's left over. You can check it by distributing backwards. 3 times 4 is your 12. You have 3 C's times 1, which is 4 C's, and then 2 D's. 3 times 5 is 15. 3 C's times no C's will give you 3, and then D squared times D squared is D to the 4th. Number 9.